And the Cloud Architecture Summit continues with more useful info on developing and managing cloud projects. And for this session, let me welcome back Austin Parker, Principal Developer Advocate at Lightstep, a software observability platform. Austin, welcome back.
Great to be here.
We're glad to have Austin with us. As you'll see, Austin is all about delivering observability for developer teams in a human-centric way. And in addition to his role as the Principal Developer Advocate at Lightstep, he is also the maintainer of the Cloud Native Computing Foundation's Open Tracing and Open Telemetry projects, which started as observability solutions, many of you may know, at Google. He is also the co-author of an upcoming book from O'Reilly, Distributed Tracing in Practice. And in his session this morning, Why Human-Centric Observability Matters for Microservices, Austin's going to tackle the issue of modern cloud projects. We all know that they've resulted in an explosion of complexity for organizations of every size. New systems architectures with microservices, containers, and even serverless are driving new innovation for sure, but unfortunately they also make it difficult, if not impossible, to keep all your stakeholders on the same page. So HCO, Human-Centric Observability, is a methodology around people, not machines. And in this session, Austin's going to take us through how HCO serves three key groups: external users, internal users, and engineers. We're also going to see Lightstep in practice with a quick little demo. So just a reminder before I hand it to Austin, you can download his slides. I highly recommend you do. You'll also see some other great downloads here, white papers and other assets. Just click on any of the links here and they're yours, all without any registration. You did that to join us today. And we love to have your questions, so to connect with Austin on that score, just type in the submit a question box. So with that, Austin, let me turn to you and tell us about human-centric observability.
Thank you, Vance. Be happy to. So yes, my name's Austin Parker. I'm a Principal Developer Advocate at Lightstep. If you'd like to reach out, find me on the internet outside of this, you can look me up on Twitter at Austin L. Parker. Also, I have a podcast on callmemaybe.com, and you can see my email address right there. So I want to start out, like I do in a lot of these talks, and ask a question. And that question is, how do we manage complex systems? When you think about a complex system, I think a lot of us would say, yeah, the software that I run every day, it's pretty complex. It has tens or thousands of stakeholders. It has hundreds of thousands or millions of users, but maybe even only has like 10 users, right? The interesting thing about systems of any kind, software systems, things in the physical world, is that if you're far enough away from it, it kind of feels like magic in a lot of ways, right? You can look at this in, sort of the natural world. There's a lot of important things that don't work magically, but they might as well. Example, none of us would be here listening to this without electricity. And humans, being the very clever creatures that we are, we figured out how can we kind of turn the natural world around us into something that powers our computers. So we took rivers, we put dams in front of them, and now we use that. The water goes through a turbine, comes out the other side, we turn that into electricity, and we distribute that everywhere. And that's amazing. If you stop and think about the journey of how can I use this computer to watch this event, all of the different things that had to happen and happen in sync in order to get us to this point are mind-blowing. And I think you can see that in software as well. 10, 20, 30 years ago, what did it look like to deploy a new version of a piece of software? You maybe would build a binary on your machine and copy it to a server. Maybe even before that, you didn't have a desktop. You had some sort of central server that was doing everything for you and you were time sharing. As the power of personal computing and these tools that we've built have gotten more and more comprehensive, and we've built all these different ways to sort of do things faster and better and at larger scale, all of that has led to this proliferation of tools for developers and for developing software. But if you look at these tools, it's overwhelming. The slide I've got here now, this is from the Cloud Native Computing Foundation. It's their cloud native landscape. And so these are hundreds of projects, open source projects at that. So this is all free software. This is all stuff that you can go download. And what it is supposed to do for you is make it easy to deploy microservices. It's like, oh, I need Kubernetes and I need etcd and I need Helm and I need all these different things, and they all need to work in concert. And if you told me, hey, go write some microservices, architect a cloud native platform, or build a new product, it's an overwhelming amount of complexity. And at some point, I think we have to ask ourselves, what is all this complexity in service of? How are we supposed to think about these tools? What are these tools actually doing for us? What is important to keep in mind is that tools, any tool, is an abstraction. The dam that sits in front of a river that creates power is an abstraction over these complex interactions of physics. In a similar way, if I'm using Kubernetes and I'm deploying software into Kubernetes, that is an abstraction over a bunch of features that we need to deploy software, like automatically scaling or being able to manage the health of our various containers. But what is a container? A container is also an abstraction, right? It's an abstraction over an operating system that lets us multiplex onto a single host or multiple hosts. And what are those hosts? Well, they're probably virtual machines. Virtual machines are themselves an abstraction over bare metal hardware. But that bare metal hardware is also an abstraction over basic computing components like a central processing unit, memory, hard disks. All of these things that we think about, and we maybe don't think about them that much because they just work, they're just abstractions to us. Similarly, programming languages. There are high level languages, things like Java or C Sharp. They're great. I don't have to think about how am I managing my memory or every single bit and byte that works. I can be very productive writing in a high level language because the language handles a lot of the important underlying computery bits for me. It handles those abstractions for me. What all these abstractions have really, accomplished for us is that they make it easier for humans to build software. Back in the day, 30, 40 years ago, even 20 years ago, if I wanted to write high performance software, I would need to know a lot more about how to write software and how to write assembly code or C or other lower level languages. And what we found as sort of an industry, as sort of practitioners that are building and running software, is that's not super scalable. So as we've built these tools and these abstractions over complex subjects like memory management or whatnot, it's been really good in the sense that it's made it easier than ever to write large scale pieces of software that can serve millions and millions of users a day or even a second. But it's also kind of broken some of the fundamental models that we have of how to understand what our software is doing. So the way we understand what our software is doing, this is maybe more traditionally known as performance monitoring or performance management. Historically, that's been a lot of looking at machine metrics, right? Looking at CPU utilization or memory utilization and using those signals to try to understand what's happening in the software. Recently, over the past 5 years, let's say, there's kind of been this traditional understanding, consensus almost, about what are those abstractions. And there's this concept of 3 pillars: metrics, logs, and traces. Metrics are some sort of time series metric. You can think of this as like a counter. How many requests am I getting per second, or how much memory am I using on a host or in a container? Logging statements are they're logging statements. They're a string of human readable text that says a thing happened here. And then traces, distributed tracing is sort of a newer part of this, but the basic idea of a distributed trace is that it shows you in the context of a request every single sub request that happened as part of it, right? It shows you all of the calls from one microservice to another. The unfortunate part about all this is that people presented these 3 tools as sort of separate experiences, as separate abstractions. And there's an expectation that you need metrics and you need logs and you need traces, and then they're all going to be in different places and they're not going to really correlate to each other. They're not going to interoperate with each other that well. And in practice, those 3 pillars really lead you to I think, an observability anti-pattern. Because what they do is they lead you to this idea that tools are observability. Unfortunately, tools are not observability. You can't buy observability, despite what some people will tell you. You can't go down to the observability store and put a bunch of observability in your cart. It's not a thing that just happens because you installed the right tools or because you started using Prometheus and Elk Stack and Jaeger or whatever, right? Observability is really a cultural thing about how you think about performance and about how you talk about performance and how you understand the operation of your system using the telemetry that your system outputs to you. And as part of this, observability is really more about your organization and about your people. So I think that's a really interesting point because people have done studies. I want to call this specific one out. The influence of organizational structure on software quality. This was published in 2008. And this was done by some people at Microsoft and a couple of academic institutions, I believe. But what they did is they wanted to see what goes into software, like what makes quality software, right? Because there's a lot of theories about this. Some people will say, well, if you have enough code coverage, then code coverage and tests, that's going to mean you have good software. Some people will do sort of static analysis and identify things like code complexity, how many dependencies you have, various sorts of pre-release quality assurance testing. All those things are sort of the panacea of, oh, this makes software good. What they found in their study, though, is the actual single best predictor of software quality was organizational structure and how people were working together and how they were managed and how their teams kind of functioned. And that's fascinating to me because it means, to me at least, that it really isn't about these tools that we're building. It's more about how we're using those tools and how those tools influence sort of the people and the processes and the organization themselves. And some of this I think is pretty straightforward if you step back a second. Are you going to have high quality software if the people that are responsible for running that software are constantly burned out because they're dealing with alert fatigue or because they're waking up every day at 3 a.m. because they're getting paged because something failed? Those sort of people issues are, I believe, the biggest problem and the thing that is really going to hurt your software quality versus having or not having any specific tool. And so that's why I talk about human-centric observability. If the people and kind of your organizational structure and how you're making decisions and how you're putting this all together, if that's what's most indicative of defects, then the solution to that, the solution to having high quality, scalable software in production, also has to put those humans at the center of it. But it's not just the people that are running the software that we have to think about, because there's a lot of things out there that will say like, oh, make your engineers happy. Cool. But there's more people than just the engineers that are maintaining it that are sort of a stakeholder in it. There's more people than the people that built it that actually need to make sure it's up. So let's talk about who human-centric observability is really about. There's three groups primarily. Our first one, most straightforward one, is your external users. These are your customers. They're people that are adding things to their cart or listening to music or buying coffee. Whatever it is that your product, that your company does, those are people that are going to benefit from your observability practice. There's another closely related group, and that's internal users. And when I say internal users, what I mean is there are people in your organization, in your company, that either explicitly or implicitly rely on it. Now, those could be other engineers on other teams who have your service as a dependency. That's one type of internal user. But it's also business analysts, it's also salespeople, it's your marketing and your support staff, and it's really everyone that has some stake in the health of the software. Those are also users that you need to think about when you think about observability. Finally, your human-centric observability is going to serve the engineers. This is the people that are responsible for it. They own the product, they own the service, they're responding to pages, they're fixing bugs, they're doing the work that needs to be done to improve, maintain, and keep the service healthy. Ultimately, all those people are users on some level. And all those people, those internal, external users, those engineers, they kind of all care about the same thing. They care about what we call the golden signals of throughput, error rate, and latency. Those golden signals are aggregate data sources. They're aggregate data points that we can get from your service using telemetry data. And we can take those and use them in interesting ways. And the result of that are sort of these human-centric observability goals. So one of those goals is to build user empathy. So not only empathy with your external users, but also your internal users. So for your external users, what do they care about? Well, they care about the latency, the error rate, and the throughput. If someone wants to add something to their cart, then it should work. If someone wants to buy a cup of coffee, they should be able to buy a cup of coffee. And if the performance of your service, your individual service as part of this whole that serves that need isn't working well, then it's going to cause a problem for those customers. When you're looking at aggregate metrics and aggregate statistics about user experience or about performance, maybe you say, we want 4 nines, right? Or we want 3 nines. So 99.9% of requests should be successful. Well, what about that 0.1%? Who are those people? Ask yourself the question always when you're looking at metrics and you're looking at sort of these roll-ups, who is getting left out? Because you can find some really interesting things about who you prioritize both internally and externally through those questions. Finally, observability lets you tie multiple sources of data together. So you can take your user analytics and your performance data, mesh it together and say, well, we see that people are falling out of our funnel at some point. Like people are getting to this point in the app and then they stop. Why do they stop? If you're able to correlate the underlying performance data to those analytics, then you can start to find interesting insights like, oh, it's because the performance is great up to this point, but then it falls off. You can also build empathy across your teams through human-centric observability. And so this isn't just between engineering teams, although I think that's very important. I think it's all too common, and hopefully people listening to this haven't had to deal with it. But when you're having an incident, when something is down, when a service is broken, it's very stressful for everybody. And emotions run high, people say things they don't necessarily mean, but it leads to some really negative outcomes in terms of the cohesion of your engineering group. If you have managers and teams blaming one another, finger pointing, then that's not great. If you have a culture of blame rather than blamelessness in how you're thinking about incidents and downtime, then one thing I've seen at several companies, horror stories, I guess, but this idea of vanity metrics where people find some innocuous part of their application or their service that they can say, well, look, we have great uptime on this thing. And even though that's not on the critical path, that's not like the part that's actually breaking, people will use these sort of vanity numbers in order to win arguments or try to jockey for political position or whatever. And that's not great. That doesn't breed a good, healthy, trusting environment. That makes people want to also make their own vanity metrics. And pretty soon, no one has a shared grasp on reality anymore. So observability helps resolve some of this because it isn't looking at just like these 3 pillars. It's looking at using these tools holistically. So it's using tracing to provide a single truth about requests that everyone can understand, even if they don't own all the services that are part of that request. Finally, human-centric observability can help you build business empathy. And so what I mean by business empathy is that as an engineer, kind of before I did this, I always thought it's like, oh gosh, those PMs, the management just doesn't understand. We really need to go and do all this performance work. But the people that are saying no, oftentimes, most of the time, all the time, let's say, have their own things that are stressing them out, right? They have their own objectives. The best way to make an argument for doing your performance work, doing your gardening, is to have data. It's to be able to say, hey, I get that you have your own stuff going on, and I get that we have these priorities, but here's insights that actually show us, that actually tie all this together and let us see where we need to invest our time. Ultimately, even if you're not an engineer, if you're at a company that runs off of software, and I would say pretty much every company does at this point, everybody needs to care about what's going on in prod. Everybody from the lowest to the highest level needs to understand the performance of their software in production. And observability is about providing access to the data and the insights that you can get from your data without gating it behind a lot of confusing dashboards or query languages that aren't accessible to people that are maybe project managers or other analyst roles. So we've talked a lot about what this is for. I want to talk a little bit about some solutions and how you can create human-centric observability at your organization. So the first thing you should do is think about how you can incentivize this from a cultural point of view. The thing you do need, the requirement to get observability, is high quality telemetry. So first off, look to the open source world, look towards projects like OpenTelemetry as the foundation for your observability efforts from a technical perspective. You can use OpenTelemetry to instrument shared code, shared frameworks, and libraries that make it easy for people internally to adopt tracing. And like I was saying earlier about incident review, if this is a problem for you, if this is something that has happened and you're like, gosh, how do we fix it? Think about observability, think about tracing and the things that it unlocks in observability as a way to fix this culture or help repair this culture. I think the first way to do it is to get everyone on the same page in terms of this is how we're doing things now. This is the data source we're using. We're not letting people just kind of go off and do whatever. The second thing you can do is when you're thinking about observability, we often talk about SLOs, right? These are service level objectives. So make sure that your SLOs are focused on business goals and not on machine metrics. And it sounds simple, but a lot of times it can be tricky to grasp. So most people tend to think about service health, I think, through synthetic endpoints, synthetic health check endpoints that are being pinged every second, and that's the source of truth. But think about them in terms of the actual business outcome that you desire. So rather than 99% of requests to succeed, well, maybe 99% of the time when I add something to a cart, it should work. And as part of that, look beyond your host level, your machine level metrics. Things like CPU utilization, host count, stuff like that aren't really interesting most of the time unless they're contributing to some negative outcome tied to a business goal. Yes, if I'm running out of memory, that's a bad thing, but only if my platform, if my deployment is not able to scale up and handle that load. So focusing on detailed metrics as opposed to those aggregates and understanding why these things are happening is, I think, an anti-pattern for this. And finally, tie your analytics and other indication of like user experience to your SLOs along with your telemetry data. So if you're using user tracking tools, things like full story to view how people are going through a web page, or various analytics events going through Segment, like connect all that stuff together and make that part of the SLO as well. Because a confusion index almost is a good way to think about this, where you want some percentage of people that are not confused by what's going on in your tool or in your product to be a measure of success. Lastly, avoid selfish tools. So we started out talking a lot about tools, and we'll finish talking about tools in a way. So selfish tools are really anything that you need someone to interpret for you. Unstructured and even sometimes structured logging can be a selfish tool because there's going to be a lot of biases and assumptions that are baked into how those logs were added in the first place so that people on other teams might not understand. So either you're going to have to document all this stuff forever, or you're going to have to, what if someone leaves and now no one understands what these log statements mean? Avoid selfish tools, look for more general things. Ultimately, there's two things that observability is going to do for you: improving SLOs and restoring SLOs. And in both of those cases, it's not the tools, it's the people. The tools can be helpful, but it's the people that are at the heart of your system, the people that build it, the people that run it, the people that use it, and the people that it serves. So what does some of this stuff look like in practice? We'll take you into a really quick demo of Lightstep, just show you a little bit to get you started. So this is Lightstep, the tool. Let's say I was an iOS engineer and I was getting paged because something was slow. So I'm able to go into Lightstep very easily, look at my service, my iOS service, and look at a regression where I see, yeah, the performance here isn't that great. I can compare these things, a normal behavior versus abnormal behavior, and then really easily say like, well, yeah, something's weird here. Let me look at everything that's going on. And with this, I'm able to see into my backend services. I'm able to see like, oh, this cache service, this inventory services is not working well. So that's something that at this point I would have the option of kind of doing more digging and going in and trying to figure out what was going on myself, or I could simply go on to Slack or Teams or whatever and message the people that own the inventory service and say, hey, there's something weird here, right? And give them the information they need to go find it. So again, there's a lot that Lightstep can do outside of this. I wanted to just kind of wet your whistle. If you'd like to know more, and I really encourage everyone to do this, if you can please go to lightstep.com/play and play with our sandbox. We have a bunch of different data in there loaded up that you can see and explore, and we'll walk you through how the tool works. It's completely free. You just put in your email address and go. Again, that's lightstep.com/play. And that's all I've got for today. So thank you very much. And Vance, back to you.
Austin, thank you. Thanks for a really great laundry list of some issues that I think a lot of our audience can totally identify with when it comes to not just individuals within a team, but multiple teams getting their cloud projects on track and launchable and scalable. So a terrific session, and who doesn't love a demo?
Who doesn't love a demo? That's what I always say. So thank you so much for having me. And if you've got any questions for me, I'd love to talk with you a little more about all this.
You know, Austin, just to get a sense of how Lightstep works into the current ecosystem that many of our attendees probably have in the enterprise right now, a question comes in, caught my eye too. How is Lightstep different from traditional APM tools like a New Relic or a Datadog?
So thank you. I think that's a great question. And what I always like to tell people is, the sort of traditional monitoring tools like New Relic or Datadog aren't really competitors, and they're very much doing something different than we are, right? They're focused on these complex dashboards and having these 3 different products and tabs that you can kind of go through. Whereas Lightstep is really more focused on the outcomes of your technology and the outcomes of saying, hey, when something is broken, I don't want to have to go in and do all these queries. I don't want to spend a bunch of time like digging through dashboards. I just want to see what's broken. I want to find those regressions and fix them. And so Lightstep is more focused on that outcome of sort of really quickly restoring your SLOs, restoring performance to your services than traditional monitoring tool would be.
Oh, so a good point. So does that infer that Lightstep has some level of diagnostics or modeling inside that it can actually readily identify the problem and not just show me a yellow light or a red screen?
Absolutely. So Lightstep has a couple of interesting features here. So one is critical path detection, where we're able to look at sort of every request and tell you exactly what the critical path of that request was and show you where maybe if something is not broken, it's just slow and you want to see where all that time is being spent, we can show you that very easily. But the other thing we can do is if there is an error, if there is some sort of failure case or failure state in your services, yeah, we can show you exactly where that is and let you drill down to it. Even if you aren't super aware of your entire architecture, maybe like in the demo, I'm like an iOS engineer, I only kind of know about my client app and maybe a few things beyond that. I wouldn't necessarily know, hey, go to this inventory service and look at the cache logs. With Lightstep, as we showed earlier, you're able to really easily see, oh, that inventory service is what is contributing latency to my request overall. So we help you model your system automatically and then identify those problems proactively when you're looking for them.
Fantastic. You know, Austin, another implementation sort of question here. Maybe enumerate a little bit where I can use Lightstep. Talk a bit about the integration you've got with popular tools and how you work with the general cloud platforms or container architectures. It sounds like you're very agnostic, or at least aim to be. Give us a laundry list of where I can use it.
Absolutely. So we are built on open standards. We're huge supporters of open source projects like Open Telemetry and Open Tracing. We also support ingesting data from other, maybe if you've used a tool like Jaeger or Zipkin to instrument your software in the past, we'll also accept that data. There are plugins and integrations for hundreds of libraries and frameworks, everything from like Spring and Java, ASP.NET, MVC, and Web API. You can integrate, we work out of the box with service meshes like Istio on sort of the Kubernetes side. So if you're using Kubernetes and a service mesh like Istio, you can just kind of get tracing for free just by turning on a feature. We work with tools like Envoy. Really, there's just a huge amount of integrations out there. If you go to our website, we have a list of them. Also, we support open tracing and open telemetry as well. So if I was going to list them all, we'd be here all day, you know?
Well, that's okay. I get the sense that if I am a generic cloud developer, it's going to be pretty easy for me to seamlessly bring Lightstep into my environment.
I would say that's accurate, yeah.
Okay, cool. Austin, it's great to get a sense of the technology capabilities you've got in Lightstep and the architecture patterns. As far as use case, I got a question here. Can the speaker highlight how Lightstep would support us in a traditional DevOps environment or maybe to accelerate delivery of CI/CD pipelines?
That's a really interesting question. I've seen a couple different interesting ways to use this. One is you can integrate it into sort of your CI/CD pipeline itself, and say you have some sort of DevOps team or someone that's delivering sort of that CI/CD experience for the rest of your organization. They can use Lightstep to sort of profile and understand their build system. They can see, hey, where are things taking a long time? You can integrate it and look at your deployments. So one thing personally I think is really interesting, and I've played around with it, but let's say you're using a tool like Ansible for deployments. You could write an extension for Ansible that actually took sort of that timing and logging data from Ansible and put it into Lightstep, and then view sort of your deployments and you're building out new nodes or whatever in Lightstep, and that would give you some ideas of like, hey, what's taking a long time, or where can we improve performance? Or if you have a continuous delivery pipeline, then you'd be able to look at Lightstep and figure out where things are breaking. I feel like over the next year or two, like you're going to see a lot more interesting kind of movement on the open source community, integrating into sort of those CI/CD and DevOps workflows.
Yeah, that does seem to be a trend, and that's a great couple of use cases there, Austin, that you shared, because I think it kind of helped put the light bulb on for where folks could get some hard results right away with their DevOps teams, for sure. Time for a couple more. We talked about the delta between Lightstep and APM. Maybe we can talk about it in the context of alerting. There's a question here that says, if I use alerting software, such as PagerDuty, what role would Lightstep play there?
So another great question. Lightstep integrates with PagerDuty. It has its own alerting functions, so you can put a query in about a particular service or about a particular API endpoint and say when the latency or error rate creeps above this level, send me an alert. And we can send those through PagerDuty. We can also send them through Slack or custom webhooks. So there's a lot of ways.
Excellent. Austin, you mentioned OpenTelemetry and some other CNCF technologies. Talk about how a Lightstep embeds within OpenTelemetry.
So Lightstep is one of the co-founders of OpenTelemetry. Our CEO, one of our founders, Ben Siegelman, was instrumental in helping to create and work on Dapper, which is the granddaddy of all of these distributed tracing systems, while he was at Google. And he was one of the founders of the Open Tracing project several years ago. And now that we've kind of merged Open Census and Open Tracing into OpenTelemetry, it's been really remarkable to see how many people are kind of coming out and standardizing on this technology. So Lightstep is an active participant in the OpenTelemetry community. We are maintainers on several projects. Lightstep as a product will support the OpenTelemetry data format when it's standardized. So if something works with OpenTelemetry, it'll seamlessly work with Lightstep as well. And we're just really excited about the growth of standards-based telemetry projects like OpenTelemetry, because ultimately, one thing that I think turns a lot of developers off of sort of observability is they think they have to do a lot of work in order to make their software traceable. OpenTelemetry, the goal is to make all of that telemetry just a built-in feature, and we're pushing towards a future where this is just a checkbox where you already have OpenTelemetry if you're using Spring or ASP.NET or whatever framework that you like.
Wow, that's a great vision. Now, until we get there, I think a lot of people are going to want to go hands-on on their own. We had time for a demo, but it was a bit of a short one. What would you recommend, Austin, folks take the next step to get their hands on with Lightstep?
The best way, if you want to learn more about Lightstep and want to really see what the product can do, is again, go to lightstep.com/play, and that'll take you into our sandbox. All we ask from you is an email address, and that will walk you through really the entire product. We give you some scenarios that will help you step through and show you how everything works, but you can go in and play around with it. We also offer a free developer account. So if you Want to play around with this at a small scale, then you can go and sign up for free on lightstep.com. We'll get you in there. If you'd like to learn more about the open source stuff that powers Lightstep, Open Telemetry, then check out that website. It's opentelemetry.io. And if you want to talk to someone, go to lightstep.com. There's a form you can fill out, and we'll have someone reach out to you.
Fantastic. And so just for my own education here, Austin, you mentioned the word play. It made me think that I was going to play a video, and you really underscored that play in your Lightstep world means you get to play around.
Yeah, you get to play in the sandbox.
Very good. That was a great session, and thank you very much also for the demo and the Q&A. Austin Parker, Principal Developer Advocate at Lightstep. Again, a up-and-coming software observability platform that lets you develop and ship code with confidence and at scale. A really great session and really great interaction with our attendees. Thanks very much.
Thank you so much for having me.
And as we mentioned, there's a lot going on at Lightstep. So we've got these great links and downloads, including the link to the Play Around portion of the Lightstep website. And we've also got some other assets directly taking you to the Lightstep web areas. Download Austin's slide, and these links will also be live. Thanks again, everyone.